this portion of the chapter, we'll be solving more rational equations. Notice they're a little bit more difficult because now we have addition and subtraction on one side of the equation. To make things easier, however, I will allow you to, there's a trick where if the denominators match on every single piece, you can ignore the denominators and just focus on the numerators. This does help us out. So that's what we're going to focus on today, is getting matching denominators. So if we look at number 1, we notice that if we multiply the two denominators on the left, it will be equal to the denominator on the right. So in reality, we will multiply the first fraction by x plus 5, both top and bottom. And then the second fraction will be multiplied by x minus 5, top and bottom, so that we have an equal denominator. Once we do that, the numerator of the first fraction would just be x plus 5, because 1 times x plus 5 is x plus 5. And the numerator of the second fraction would be x minus 5, because 1 times x minus 5 is x minus 5. Keep in mind that the denominator would now be the product of those two quantities together, which is x squared minus 25. So I'm not even going to write it because both sides of my equation will have matching denominators. So I can focus on the numerators given that all three pieces have matching denominators. Doing this, I will recognize that a plus 5 and a minus 5 is a 0. So I have 2x equals x plus 3. So x is equal to 3. I still need to check this answer in the first equation to make sure it's not extraneous, meaning left truly does equal right, and that there are no undefined terms. And then if I check that out, 3 ends up being just fine, so that is acceptable. Let's look at number 6. Again, the goal is to have 3 terms here with matching denominators. So the only one that doesn't match is the 1. So 1 could really be thought of as x minus 4 over x minus 4, right? That fraction has a value of 1. Also, the denominator matches. So we're going to switch out the 1 with that fraction. Again, once all 3 denominators match, we can just ignore the denominators. So the first term has an x in the numerator, plus the second term has x minus 4 in the numerator, and the third term had a 4. So it's 2x minus 4 equals 4, which is 2x equals 8. So x is equivalent to 4. I need to put that back in the original equation to make sure it works out. And we will notice that x equals 4 is actually an extraneous solution because those denominators will not turn out very nice for us if we put a positive 4 down there. Let's try number 2. Again, we notice 2 of the 3 terms have a denominator that matches. So let's go ahead and give that denominator also to the second term, the 6, by multiplying x minus 1 to both top and bottom. So I'm not going to write the denominators because we know they're going to match. My first numerator will be a 3 minus 6 times, remember that both top and bottom would have gotten an x minus 1 and a 5x. So when we combine terms, we're going to get 3 minus 6x plus 6, right? It's a positive 6 getting distributed here. Equals 5x. Okay, so a negative 6x gets distributed, so I get a positive 6 in that term. When I move things around, I'm going to get 9 is equal to 11x. So my answer will be 9 over 11. I put that back in to make sure everything works out. It does. So we are perfectly happy with 9 over 11 as a solution. Let's look down below. Okay, let's look at number 9. Notice all three are different. We do not have a common denominator. So what we're going to do is we're going to take the product of the first two and also give that product then to the 2 that is alone on the right. So the product of this would be x squared minus x minus 2. So the first term is only missing the x minus 2. So the numerator would be multiplied by the x minus 2 term plus the second term. The second term already had an x minus 2. It requires the x plus 1. So it'll be x, that's already in the numerator, times the x plus 1. However, the 2 on the other side, it needs both pieces, so we're going to give it that entire quadratic. So when I combine and distribute, I have that. We'll set it all to one quadratic. So let's take everything on the left and move it to the right because that will keep our x squared term positive. So if I'm going to move everything, I have 2x take away, 2x squared take away 1x squared. I'm left with 1x squared. I have negative 2x on the right. I'm going to be adding 2x from the left and taking 1 away. So that leaves me negative 1x. There are no constants on the left, so I just still have 4 over here. So when I factor this, and I run it through either a calculator or I factor it however I want to factor it, either way you do it is fine. Excuse me. You can plug it into a calculator. You can use the quadratic formula. You can put the solver in there. However you want to check for your solutions. I'm going to put it into a calculator. So if you have the fancy one, you can just use your polynomial solver to a good degree of 2. And you put in your terms. Oops. Messed that one up. Has to be a negative 4. Okay. And I get 2 very different answers, but I will get 1 plus or minus the square root of 17 over 2, which yields 2 different decimals. But you put those back in. They're clearly not undefined. You can check them out. They work. They're good. The answer is funky, but it's the answer, right? There's 2 of them there. 2 separate answers. We put them in, make sure they work. Okay? That's all we do is we make sure every single term has a common denominator. Then we go ahead and just solve the numerators.